When we size circulators, there are two important numbers to remember: 2.31 and 0.4332. These are constants or known values that we use in our math to determine how much force we need to generate the correct amount of flow. But what do these known values represent? The weight of water. Take a look at these two pipes. One pipe is 12 inches tall. The other is 28 inches tall. If we fill these pipes with water and place a gauge at the bottom of each, we can read the pressure the weight of water generates on these two different columns of water. The pipe that is 28 inches tall will have a gauge pressure of 1 psi. And by the way, 28 inches happens to be 2.31 feet. So we have our first known value. This means 28 inches of water column equals 1 psi. The pipe, which is 12 inches tall, will generate a pressure on the gauge of 0.4332 psi. This means 1 foot of water weighs 0.4332 psi. This represents the amount of energy we lose for every vertical foot in our system. The size or shape of the pipe doesn't affect us here, since we're considering pounds per square inch and not total volume. Brace yourself, it's time for some simple math. If we have a system 20 feet tall, we can calculate the static pressure on the system. 20 feet times 0.4332 equals 8.664 psi. Or we can do the math a different way. 20 feet divided by 2.31 equals 8.658 psi. So this means it takes almost 9 psi to get to the top of the system. But what if our system was 100 feet tall? Well, 100 times 0.4332 equals 43.32 psi, or 100 divided by 2.31 equals 43.29 psi. So it would take almost 44 psi to get the water to the top of the system. This is a problem as most relief valves are set for 30 to 50 psi. High pressure on the boiler can cause the relief valve to leak or dump. This is why we place the heating equipment on the roof when we have very tall systems. If our boiler is on the top of the system and we maintain the system with a standard 12 psi, we can calculate the pressure at the bottom of the system with the same math. 12 psi static pressure plus 43 psi, or the weight of water in the system, equals 55 psi at the bottom. Understanding the weight of water and how we overcome it is a fundamental principle of hydronics. Thank you for watching.